Higher order polynomials. When I talk about a higher order polynomial, I'm talking about a polynomial that looks like that. In this case, it's a third degree, but generally I'm talking about a polynomial that has a higher degree than the second degree. I'm talking about higher degree than 2. With a polynomial of the second degree, it's a little bit different from polynomials of higher degree in that generally we spend some time looking for the vertex. We find the Y-intercept, the zeros, and the vertex. Well, with these higher order ones, we generally don't think about the vertex. So let's see what we would do, how we would deal with a polynomial like this. First, we need to be able to find the Y-intercept, and we find that by letting x be 0. It's always what we do. And that is an easy process because when you let x be 0, all these terms zero out except the number on the end. So we've just got the Y-intercept of -1. Now, as far as finding the zeros, this part can be quite challenging. But just to introduce this, I've picked one that is easy to work with. So the way you find the zeros is you take the whole expression here and set it equal to 0. It's like you're letting y be 0. See? So I just replace f of x with 0, and then I solve it. Now, if we're going to solve this equation algebraically, we need to be able to factor it. And I've picked one here that will factor into this. Now notice we've got these factors. We've got this factor times this factor times this factor equaling 0. So it's easy for us to find solutions. Any value for x that will make any one of these factors 0 is a solution. So here's what we have. -1 will make this factor 0. So if I put a -1 in here, this whole thing is 0. So that's a solution, see, from this one. For x minus 1, well, if x equals 1, that's a solution. And over here, if x, well, we have 2x plus 1 equals 0. That's solved whenever x equals -1/2. So here we have the roots, the zeros. Zeros, roots, they're the same thing. And also, in this case, the zeros and the x-intercepts are the same. So this is where this graph crosses the x-axis. Now let's take a look at how we could use this information to get a sketch of this polynomial. This is what the polynomial looks like, okay, if we look at the graph of it. Now notice we have the y-intercept here. We have the roots here, the x-intercepts, -1, -1/2, and 1. Now, the way you can make a quick sketch of this polynomial is go to the y-intercept. Label the x-intercepts up here. Start at the y-intercept and simply start tracing it. Just draw the curve up, making sure you pass through the x-intercepts. Okay, so it goes up, pass through here, and then pass through here. Okay, same way on the other side. So let's look at that one again. So we're going to start at the x-intercept. I'm going to go up, pass through the x, and then I just make sure I pass through these x-intercepts. Whoops. Okay, here we go. Passes through there. Go through the other side. I'm going to go up and pass through this. Now, I don't have any more roots over here. I don't have any more x-intercepts, so it just goes off to infinity. Okay, let's look at another example. Now, what we're trying to do is look at a polynomial like this and try to get some sense of the general behavior of it. In other words, get some sense of what a rough sketch of this would look like. So I want to observe the behavior of this polynomial by looking at its graph, and I don't want to take the time to enter it in my calculator. I just want to be able to look at it and say, oh, I know generally how this polynomial is behaving. Well, what we use to figure that out is the y-intercept and the x-intercepts. So let's look at the y-intercept. We find the y-intercept by plugging in a 0 for x. And when we do that, notice the x's just go away and we're left with this, which if we multiply that out, we get 6. So we know that the y-intercept is 0, 6. Now, let's look at the zeros. That's when we set the whole thing equal to 0. Now, of course, you see the factors here. We want to know the roots, the zeros. So here we go. Obviously, x minus 2 means x equals 2 is a 0. X minus 1 means x equals 1 is a 0, and so forth. Now, what I want to do is look at the graph and see how these relate. Notice we have a y-intercept of 6. So over here is a 1, 2. See there? X equals 1, x equals 2. Over here is x equals -1, x equals -3. Now notice how I can get a real quick sketch. I can start here, and this is a rough sketch. I can start here at the y-intercept and just trace. Cross right there at -1, keep going. Loop around, come back up, and then cross at -3, and it doesn't come back down to cross again, so just keep going up. This is just a rough sketch now. Now to get this other side over here, I start here, come down here, cross at 1, turn around so that I can come back and cross at 3. And this is how we can get just a rough sketch. We're not paying attention really at this stage to how far down we go before we turn around and come back up. Okay? I don't pay attention to how high this polynomial, where's the peak here or where's the valley here. I don't pay attention to that. I'm just wanting to get an idea of the general behavior. Okay, let's look at this one. Now, still, I want to find the y-intercepts. So I replace all the x's with 0. And when I do that on this one, I get a -6. See? Because this is -2 times 3, that's -6 times a +1. This -1 is squared, so this just works out to be -6. Now, one of the things you'll notice about this is this factor here, it's raised to the second power. Now, this polynomial here is not a 4th degree polynomial like the other one was. This is when you multiply these two out, you get a cube. Then when you multiply this with it, you get a 4th degree. And then when you multiply this with it, you get a 5th degree. So when we multiply all of this out, we get a 5th degree polynomial. But that's not really important right now to think about. What I want to focus in on is this square here. Now, I'm going to go ahead and solve this. And I get x equals 2, x equals 1, because it doesn't matter if it's squared there. If x equals 1, that's a solution to this equation. X equals -1 for there, x equals -3 for here. But here's the thing. All of these factors here are raised to the first power. And so we say this, we say that x equals 2, that's a root of multiplicity 1. X equals -1, a root of multiplicity 1. X equals -3, a root of multiplicity 1. However, this one right here, it has multiplicity 2 because it's raised to the second power. If it was x minus 1 to the third power, it'd be multiplicity 3. But let's see what effect that has on the graph. Here's a sketch of that graph. Now notice, at x equals 1, notice the function, the graph does not pass through the axis. It bounces off of it. Now this is going to be the case when we have even multiplicity. If this had been 2, 4, 6, 8, any of those numbers, you're going to have a bounce going on. If it's an odd multiplicity, it's going to cross right on through the graph. So dig how this works. We start here at -6. We come up here, coming up here, hits the graph, doesn't pass through because we have multiplicity 2 there. It bounces, comes down here, turns around, and passes on through. Down here we start at -6, comes on down, comes up, crosses through, comes up way up here somewhere, and then passes back down. But the thing I wanted to point out with this problem was what happens when you have a multiplicity 2. Now let's look at this one. Let's suppose that we have this one to graph. So we want to find the y-intercept. And of course, if you replace all the x's with 0, you just get a 0. So the y-intercept on that one's easy. Now, let's look at the zeros. What I'm going to need to do is I need to factor this thing, okay? I set it equal to 0. I factor it. I factor out an x, first of all. Then I need to factor the rest of it, right? So remember, that's the first step in factoring. You factor out a common factor. Then you look for other methods. And we see that this thing factors into this three factors. Okay, so what this means is x equals 0 corresponds to that factor, x equals 1 corresponds to this factor, and x equals 3 corresponds to this one. Now, all of them have multiplicity 1, so, I just wanted to point that out. Now, let's look at what the graph looks like. If we were going to sketch this, I would start here at 0, and the question is, how do I know which way to go? In other words, when I start here at the y-intercept, do I go down like this? Obviously I do, but how did I know I wasn't supposed to go up like this? Like here, notice how this graph is sketched. I go up, down, and then back up. How did I know I don't go down, up, and then like that? So there's another thing that we need to pay attention to if we're trying to determine how a graph is sketched, how a polynomial is sketched. We need to pay attention to what's called the extreme left and right behavior. In other words, what does the graph do? Way out here for large values for x, and also in the other way for large in the negative direction values for x. What does the graph finally settle down to? Now this one, notice it goes up to the right and down to the left. Up to the right, down to the left. That's how we describe it. And notice it's an odd power, right? Well, here's the deal. We're going to think of this, we're going to make a little table here for you, a little something that you can use. If you're dealing with a polynomial and it has an odd degree and it's even, and it's positive out front. See, it's an odd degree and it's positive out front. Then it's going to behave just like x cubed. Think of the x cubed graph and how it goes. It goes down to the left and up to the right. That's how on this one I knew start here at 0 and go down this way and then go up the other way. See? Because we want to finish out going up like that. Now, look, let me add some more to this table. If you have odd and negative, in other words, what if there had been a -1 in front of this? Well, it wouldn't have changed any of the x-intercepts, but what it would have done is turn this graph upside down, so it would have been up this way and down this way. Now, what if we had had an even degree and positive? Well, that's going to behave this way on the left and right. The extreme left and right behavior is going to be up to the left, up to the right, and if it were negative in front, it would be down to the left and down to the right. So this is something we're going to, it's helpful to us when we're trying to determine what a graph looks like to keep this bit of information in mind. Just think of how does x squared behave versus how does negative x squared behave versus how does x cubed and negative x cubed behave. Okay, so let's tie some things together here. Let's suppose I have this polynomial. Now, what I'm interested in the y-intercept, the zeros, and the extreme left and right behavior. So, let's see here. The y-intercept here is 45. See? 45. Because if I just put a 0 in here, I get -1 times -5 is +5 times 9, and I get 45. Now, as far as the zeros, I get 1, 5, and -9. Now, the extreme left and right behavior. The extreme left and right behavior, we need to know what is the degree of this polynomial. Well, we look here and we notice we've got these 3 linear factors, and if we multiply them together, we would get a 3rd degree. See, if I multiply these 2 together, I get a square. Then if I multiply by the 3rd one, I get a cube. So this is an odd degree, and it's positive. See, there's the x cubed term is going to be positive, so it's going to behave like x cubed, this one right here. So there we have it. That's the extreme left and right behavior. Now let's look at this one. Here we have, well, let's find the y-intercept first. I just put a 0 in for x. I get a 1. Now, as far as the zeros go on this one, I don't know what they are. I'm not going to worry with the zeros right now on this one. And this shows you that sometimes finding the zeros can be the challenging part. So let's skip that and go to the extreme left and right behavior. This is a 6-degree polynomial, and the coefficient is negative. So we have even and negative. So here's even, negative, so it's going to be this one, down to the left, down to the right. Now this thing about the zeros, sometimes finding the zeros is going to be the most challenging part of these three things: the y-intercept, the zeros, and the extreme left and right behavior. So it's something, and sometimes like this one, they don't have a nice factorization for you. So sometimes you have to, sometimes you're not going to have nice rational zeros. So I'm just putting a question mark there because my emphasis here is the extreme left and right behavior. And anyway, now let's look at this one. So we have f of x equals x times x minus 1. Well, the y-intercept is easy. It's just 0, right? If you put a 0 in for x. Now what about the x-intercept, or the x-intercepts, the zeros? Well, x equals 0 or x equals 1. Yeah. Now this 1 here has a multiplicity of 7, doesn't it? Yeah. See? Because there's a 7 there. Now, as far as the extreme left and right behavior, notice that this is the 7th degree right here, but then you're multiplying by this x. So this is an 8th degree polynomial. The leading coefficient is positive, so it's even and positive, so it's going to look like this. There you have it.
Okay, so let's see how we would go about getting a rough sketch of a polynomial. Now, let's consider this one right here, this a of x equals x minus 1, x plus 2, x plus 3. One of the things I'm wanting is I want to find the y-intercept. Okay, so the y-intercept is what I'm going to get when I let x be 0. So let me find that first. The y-intercept is going to be negative 1 times 2 times 3. See, I just replace the x's with a 0 and I get a negative 6. So let me I'm just going to, haphazardly just put it somewhere down here, because all I'm trying to do is get an idea about, how this looks, the general behavior of the polynomial. Now, as far as the x-intercepts, notice I have x equals 1. Okay, there it goes. X equals 1, x equals negative 2, and x equals negative 3, like that. Now, if I want to just get a rough sketch for this, I'm going to start down here at the y-intercept, come up like this, and then go up here, make sure I cross this one, and turn around in time to come back down and cross here. So now, I have not paid any attention to how high up this graph goes or how far down it goes. I'm just trying to get a rough sketch for the general behavior of the graph. So there's what I do there. So that one's done. Now let's look over at this one. Okay. So once again, we want to find the y-intercept. And that's we're going to replace the x with 0. So I got negative 1 squared times 2 times 3. See? Now, this is going to be, negative 1 squared is 1, so this is just going to be a positive 6. So let me put that up here. Positive 6, and then I've got x-intercept of 1, but notice that's got a multiplicity of 2. So let me just put a couple of marks here to remind me later. And then I've got negative 2 and negative 3. Because what's going to happen here is we're going to have it bounce. Remember, even multiplicity bounces. So I start here at the y, come down here, bounce, there we go, bounce, and then I come here back to the Y, and I'm just going to cross through each one of these. Whoops, kind of made it sloppy there. But it just crosses back through there. Okay, so remember, this is just an exercise in finding the rough sketch. As you can see, that's pretty rough right there. Okay, now let's look at a couple more here. Let's look at this one. Okay, so we've got our Y-intercept, and so we've got 1 cubed times 2 cubed. Well, that's just 1 times 8. So I'll put that up here, 1 times 8. Now we've got a -1 here for a root. We put that right there, and a -2 for another root. Okay. Now these are both odd multiplicities, right? Odd multiplicities. So what's going to happen here? The graph is only going to touch the axis over here. It's not even going to touch it over here. So let me just do a rough sketch here. I'm going to come down here. It passes through, turns around, kind of passes through here. I kind of leveled it off here because, you know, with a higher degree here, it's going to not just pass straight through. You would see it kind of flattening out. And then it just goes on up like this. Okay. So there's what this graph, just a rough sketch of the graph. And there are details we're leaving out here, but that's okay. We're just trying to see how to look at a polynomial and immediately get an idea about the behavior. That's all we're doing here. Now let's look at this one. The Y-intercept, Y-intercept, that's just going to be 0. 0, 0, right? Because, you know, when I put a 0 in here for x, it's just 0. Now, we've got to get the X-intercepts. And the way I'm going to get the X-intercepts is I'm going to set this whole thing equal to 0 and solve it. So I get x cubed plus 7x squared plus 10x equals 0. See, these others were already factored for us, but not this one. So then I factor out the x. Okay. That's always the first thing I do when I'm factoring. And then it turns out I can factor this a little more. I've got x, let's see here, this is going to be 2 and 5. I need what adds to give me 7 and multiplies to give me 10. There you have it. So I get an x-intercept of 0. That's one of my zeros. X equals -2. Or x equals -5. So it crosses here, here, and here. So 0, -2, and -5. So here's -2 and -5. Now the question is, when I'm sketching this, do I go down here like this, or do I go up here like this, right? Well, remember the extreme left and right behavior. This is an odd power, and it's positive. So that tells us to the left it's going down, and to the right it's going up. So we start here at the Y-intercept, go up, cross down here, cross through here, and cross through here. And there is a rough sketch of our graph right there.